Carry on.
All right. So I chose a bug as my presentation slide image. This is a skinning bug where people's face disappears, which is always a fun bug. So my talk is about RR, but I thought I'd better make it about Rust, since it's a Rust meetup. So I've just got a few kind of tips with debugging Rust. So yeah, just going to cover printing and logging, panics and backtraces, symbols and debuggers, and then debugging in reverse. So logging. So printline. A couple of small tips about printline. You've probably already seen in previous slides the colon question mark. As you can see here, prints on one line. I discovered recently if you do hash question mark, it pre-prints it. That's nice. Yeah, exactly. It's like, whoa, mind blown. So hopefully there's something for everyone. Yeah, it's pretty simple. So I personally find printline, it's good for small things, but you get like 100 people committing their little print lines. It doesn't work out well. And you got to recompile all the time, and tracking down things. So anyway, logging. It's the next step, because you can filter other people's annoying print lines. So in Rust, there's the log crate on crates.io, which I noticed has recently moved into nursery, so I guess it's going to perhaps become official at some point. And it's got nice macros, so you can categorize your log messages. And I guess it may be able to, at compile time, filter out what's coming in. I'm not really sure, but the macros look nice. I haven't linked to them, unfortunately, but I'm not talking about logging, so. Panics. I should point out, I thought this meetup was last week, so I wrote my talk ages ago, and then I spent like the last week putting images in it, which is why there's lots of silly pictures. So panics, panics happen rather than undefined behavior and mysterious kind of memory corruption. Rust prefers to panic and just exit. You can put your own panics or asserts. That's always fun. So if you give it a panic, you'll get this backtrace. Well, no, you won't get a backtrace. You'll get this thread panicked, which if you have a large program is often not telling you much. So a reasonably, seemingly well-hidden feature is this environment variable, Rust backtrace equals 1. And if you do that and you get a panic, you'll actually get a full backtrace. There is some discussion about turning this on by default. I think perhaps the reason why it's not on by default is because you get a whole lot of horrible stuff here, and if you're in an optimized build, it might not be that useful. But at least here, I can see my two functions, and if I actually had a proper program, it would probably tell me something useful. So that's good to know. So this talk will probably go quite quick. Debugging. So who here is proficient with GDB? All right. Notice I don't have my hand up. I mean, who here's kind of like uses debuggers on a regular basis? Okay, all right. So depending on what language you come from, with Rust, C, so on, you need symbols for debuggers to actually tell you anything useful. So the first step is to make sure symbols are enabled. If you're compiling a simple program with Rust C, you just use the -G flag. If you're using Cargo, the default build will have symbols enabled. The test build will have symbols enabled, and you can configure it in your Cargo TOML with these profiler sections. I mean, there's other things you can configure as well, your optimization settings and so on, but debug equals true will give you symbols. So if you want to debug anything, turn that on. So GDB is a C, C++ debugger. It might do some other languages, but it doesn't actually know about Rust. So if you just start up, same with LLDB, LLVM debugger. If you just start it up, you'll get some things, but you'll get a lot of gobbledygook when you try and print certain things. So there are some wrappers that Rust provides, which just set up some pretty printing scripts that can print some of Rust's types. It's certainly a lot better than vanilla GDB. So here's an example, a pretty trivial program that has some colors and then prints them. Yeah, pretty exciting. It's the output, woohoo. So start GDB up. Q is just quiet to hide a lot of noise. So there's a warning here, missing auto load script at offset section, blah, blah, debug GDB scripts file. Oh, sorry. That's not the warning I was interested in, it's on after it. Auto load Python scripts. So I think what's happening is Rust actually embeds the name of a Python script to load when GDB starts. I'm assuming that's what goes on. So it's complaining about it being missing. So if I continue without the Rust wrapper and just break at line 14, because I know that's exactly where I want to break, and run to that point, and then print label. Label is a string. Then I get something, like I get this big long string. Strings are not null terminated in Rust, so I get the whole string and then the length of the string. So, oh, yeah, I mean, I can see what's going on with that. For the purposes of these slides, I was trying to print the vector, and the first time I did it, it worked, and the second time I did it, I don't know, I changed the code, and for some reason it couldn't get the pointers. So, wrapper or no wrapper, it wasn't playing ball. So the GDB experience is not perfect, but you can get by. So if I use the Rust GDB wrapper and run my program again, I don't get any warning. And then when I print the string, it says label and the members of that struct. I don't know if you recall the struct. Sorry, so label's not a string. I forgot my own program. It's a struct, which has an index and a static string. So without wrapper, with wrapper, that's kind of a lot easier to understand and deal with, right? So crashes and debugging. So an example of a horrible bug. So maybe you have a couple of threads. This is, I guess, from a game kind of context. So you have a main thread and it's running a game, and you have a render thread that's processing draw commands that are generated from the main thread. This is something I kind of ran into recently. It's like in my mind. Yeah, pretty much. This is a C++ horror. Well, a horror story. This is like an average day. So, yeah. So what it looks like is like one thread's kind of got a callback with some data, and the data's like disappeared, and then it's like trying to read data that's been deleted. Who knows what's happening? Not me, that's for sure. This is one of the reasons I'm like excited about Rust. I guess the point of this, the point of this crash, something bad has happened, probably on another thread and probably in the past. So you have a crime scene, you're looking around, there's like a broken bottle and dead body, but you don't really have any idea what's going on. So it would be really nice if you could turn it all back, rewind, and see what happened. So, RR, actually, was anyone at LinuxConf? Yeah, okay, right. So there was a talk at RR. Did you go to the RR talk? Oh, okay. Well, it was more about how RR works, and I mean, I can sort of glaze over that, but this is just a very brief demonstration of what RR does. So, yeah, so the idea is you can record a trace of your program's execution. You stop your program, or it exits, or it crashes, and then you can play the trace back in GDB. You can stop at some point, like, I don't know, some known point you put a breakpoint in, or maybe when the program crashes, and then you can run the program in reverse to try and work out how it got into that state. So crash dump, or, effect, you work backwards to find the cause, how you got into that state. To me, this is very exciting. This would make my life a lot easier if I could use it. I'll get to that. So, for this to work, RR has to be able to play back a deterministic trace. Everything has to behave exactly the same as when the program originally ran. So there's lots of non-deterministic inputs into your program, like getting the time, loading a file, the high-frequency clock, for example, I guess network. What RR does is it intercepts those calls to the kernel with various magic, which I won't attempt to understand. Well, some of it, so okay, intercepts calls, but there's also other things that involve CPU counters and all sorts of things that I don't fully understand, to basically record what happened so it can then play it back over and over and over again and always the same. So there's some limitations of RR, that it's only Linux, and it's only Intel and reasonably modern CPUs. The talk on RR at LinuxConf, the author, it's a Mozilla project, so it's primarily Firefox people that are sort of interested in it. But it's really relying on like an open source kernel, various features of Linux that are available, and they said they don't really foresee it being available on other platforms because it would probably require changes to the kernel to other platforms' kernels. So sorry, that's why I can't really use it. My work is on Windows primarily, but it seems nice. So parallelism is not strictly supported because parallelism is not deterministic. RR, I think, kind of makes things concurrent, but gives each thread a bit of time to run and then records the kind of progress. It didn't like my NVIDIA GPU on my laptop. I was trying to capture one of my GL programs. It didn't like that, but apparently if you do GL, you can use this flag, and it worked for Intel. So yeah. So here's an example. This is basically, it's from the Rust book. It's on the docs. If you go to the Learning Rust, there's this thing, type in, guess a number. Pretty straightforward. So I recorded this, just entering random numbers. So the command is rr record, guess, have symbols. Actually, oh no, that's all right, yep. So playback, -d Rust GDB, so you can print things and not get complete mess. And so C in GDB is continue. It's just like run my program, so it runs to the end. So that's my input that I entered, the first time. It's just played it all back. Maybe that doesn't seem that magical, but it's kind of cool. So then I put a breakpoint in, that magic line that I remembered. And run RC, which is short for reverse continue. So that just runs the program in reverse until it hits my breakpoint. It's nice. It's nice. I mean, it's sort of spoilers because you see what I've entered already. It printed it when it ran it the first time, but yeah, if it didn't, I could go back and have a look. So I think looking at the program, oh yeah, I put a breakpoint on that match. And at that point I can print the guess, it's 93, and then reverse continue. So it will run backwards again until it hits the breakpoint again. Print the match, and prints 92. Whoop. It looks about right. Oh, yeah. Oh yeah, so the commands, you've got reverse, continue, reverse, next, and reverse step. These shorthands, you can type the full thing if you really want to. There's probably more I don't know about. Well, they mirror the kind of normal GDB commands, I guess. Next and step, yeah. Yeah, obviously there's no go for this. I didn't have time, but the other part of Rust debugging is IDE, integration of debuggers, so you kind of aren't faced with this, which, is a bit... I'm used to Visual Studio, and it's always a bit difficult approaching this. Once you know it, it's fine, but if you don't, it's a bit impenetrable. So yeah, I didn't get that far with that. I did see on the Visual Studio front, there's a project which someone did show a demonstration where they'd had a simple program. They could step into it using the Microsoft debugger, so with the Microsoft toolchain versus the GDB toolchain, and they could break into a program, view variables. I don't think the current Visual Rust plugin can do that, but I guess it's on the way. I believe Eclipse has a GDB wrapper, which if you use Eclipse, yeah, I don't use Eclipse. I thought about installing it. I run Ubuntu. Eclipse on Ubuntu's ancient, so I didn't bother. And there may be other IDEs, so you're not strictly stuck on the command line, I think, forever. Yeah, that's my talk. Has anyone got any questions? Yep. Oh, this mic's behind you.
Hello. So was there any particular reason you chose to use Rust GDB over Rust LLDB for your examples?
Not. It probably needs to match the. Actually, I don't really know. I mean, I'm used to GDB. I think if I go back, it may also depend on what Rust is using, but I'm not really sure. Yeah, I think it would probably work with either. I've never used LLDB, so
No, it's just interesting to me because Rust is generally, if not always, compiled with LLVM. So
yeah, LLVM on the back end.
it was actually surprising to me that it worked
Yeah.
relatively well at all in GDB because GDB is a fairly opinionated debugger.
Right, yeah. I'm not sure. I did ask a servo developer about this once, and he said that, it should be equivalent. Yeah.
Unmute. There we go. Because there's several people who raised their hands with GDB, I've encountered this several times with Rust programs debugging. How the freak do you add a breakpoint on a named function that is part of a trait? So there's multiple implementations of it. I want to set a breakpoint on a single implementation of it. Is there a way to do that in GDB? I've Googled and also tried and have not been able to figure it out.
I'm not sure if I've tried. I've done a little bit of debugging in GDB with Rust, but not a lot recently. The only recent stuff I've done was for this presentation. So yeah, I don't think I'd answer that.
The question was, can you do file and source line number? Maybe. I don't know GDB that well. I've only done it when debugging servo, and because you have traits that live all over the place, it's hard to figure out where to set the breakpoints.
Yeah, I mean, I haven't tried with Rust much, but in C and C++ and other GDB languages, you can do either by symbol or by source location, which might be easier in this case, where you just it's just break file : line number.
Okay.
Yeah, tab completion seems to work, but I don't know if there's some mangling that happens with traits.
Just on the earlier question about GDB versus LLDB, at least on the Unix builds, by default, Rust won't even install the LLDB wrapper.
Right.
So the Rust upstream recommends the Rust GDB for Unix and the Rust LLDB for
Probably Mac.
Windows and Mac, I think.
Yeah.
OS X, yeah, whatever. Yeah. The output file formats are the same. It's just debugging symbols and things. It's in a standard platform way.
Right. Yep. Cool.
So less of a question, but more praise for RR. I think one of the selling points on the website was that you have a continuous integration suite that is detecting, say, a flaky test 1 in 1,000, 1 in a million.
Yep.
If you run your tests within a record session, you can then get store in persistent storage the exact trace that led to this breaking, and then step through it in reverse and find out exactly why that did, for extremely rare problems.
Yeah.
So it's like an extremely useful tool to know about and get useful with.
Totally, yeah. If you visit the website, there's lots of glowing testimonials from mostly Mozilla developers that are using it. But I mean, I think genuine. Yeah.
So
they're mostly the ones
it
using
serializes like a time sharing the parallelism. So you can, as far as I understand it, emulate multi-threaded applications. It's just that it's a lot easier to deal with the to make it deterministic by serializing the execution. So internally, it shouldn't make much difference to how something executes.
Yeah, you might not pick up some sort of race conditions that depend on certain order.
It will make it slower. But
Yeah, and it makes it slower, yeah, for sure. Yeah, I mean, if you're running on Linux, your software on Linux, I'd recommend trying it because it looks pretty amazing, to be honest. If I could use it at work, I totally would. Yeah.
I'll ask one more question. Why not? So another thing that you showed was panic and stack traces, which is fantastic on Linux and possibly on Windows. I don't know, but line numbers aren't included on stack traces in OS X for the Rust panics on default. Has anybody solved that? Like, does it like? I feel like I'm being a little bit picky around the debugging story, but it's also something that's super frustrating, especially when writing tests.
Unwinding is hard. And in summary, the story is that unwinding stacks is hard. So as you're stepping down, and I'm only really aware of the story with this with C, so I've not actually played with the Rust unwinding, but the general problem is that you have to associate source locations with the executable, or the executing location rather, and that's what the symbol table is for. But this is where you need to use something like libunwind or similar, and you see references to libunwind buried all the way through that stack trace there. Libunwind is one of the, I believe there's about 5 or 6 different libraries that actually do that translation. There's a few others. Libbacktrace is another one, but it also behaves in a subtly different way. The other thing to note with unwinding is, of course, that does, you're observing a system, you modify it. So you see unwinding, you modify it. So you see unwinding